All right, 0.4 is our review of basic trigonometry. So that's our learning goal. No one can use basic trig. Most of us hopefully remember, right? We know sine, cosine, and tangent. If we set it up, if we look at it as a right triangle, right, the sine equals the opposite over the hypotenuse. So we got over here the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse. And then the tangent is equal to the opposite over the adjacent. So I take this opposite side over the adjacent side. So you kind of think about how all those are related. You guys have seen that before. The hypotenuse is opposite the right angle, right? And by the way, this is my angle down here. If this is my angle, this is the opposite side. One thing is to think about, if I move my angle up to there, then these two sides, the opposite would go down here and the adjacent would go up there. And I think most of us are pretty familiar with that. There are three other trig ratios. It's the cosecant, and cosecant is simply the reciprocal of the sine. So instead of being the opposite over the hypotenuse, it's the hypotenuse over the opposite. You just flip it over. The secant is the reciprocal of the cosine. So instead of being adjacent over hypotenuse, it is hypotenuse over adjacent. And the cotangent, that's what the cot stands for, right? It's the reciprocal of the tangent. So instead of being opposite over adjacent, it's adjacent over opposite. As a side note, don't say it as like the sin or the cos or the tan. It doesn't require any more effort to say sine, cosine, and tangent, or cosecant, secant, and cotangent. If you need to write those down, take just a second, write those down so we're saying it properly. So if you look at these examples at the bottom, it says use a right triangle to find the sine of theta. So now my angle is up here. So let's label our sides first. The hypotenuse is the easy one. It's opposite the right angle. This is the opposite side. This is the adjacent side. Okay, so we know sine, right? Oh, by the way, back up there, you'll see after the side those abbreviations. I think most of us have heard of that SOHCAHTOA. If that helps you remember it, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so sine. Sine is opposite over hypotenuse. The opposite is 4, the hypotenuse is 5. So that ratio of the two sides is 4 to 5. Cosine is adjacent over hypotenuse, so the adjacent is 3, hypotenuse is 5. Tangent is opposite over adjacent, so the opposite side is 4 to 3. Okay, when you get to the cosecant, secant, or cotangent, you just got to remember which one they go with. Cotangent is one we usually remember pretty well. Cotangent goes with the tangent. The other two are a little bit tricky. It would be nice if the C's and the S's went together, right? Sine and secant and cosine and cosecant, but they don't. So I always just remember that they don't go together. It's the opposite. So if I see the secant of theta down here, I know secant goes with cosine. Well, cosine is adjacent over hypotenuse 3/5. So secant's the reciprocal. It's the hypotenuse over the adjacent. So it would be 5/3. So that's just some really basic right triangle trig. Now, when you get into more advanced trig, especially in calculus, we're not just going to deal with a right triangle. If you think back to a right triangle again, it only helps you, right? If this is 90 degrees, then both of these angles have to be less than 90. So if you only use a right triangle, you can only do angles that are between 0 and 90 degrees. What we do then is to help us do other angles is we put the angle on the XY axis like this. We put it in what's called standard position. And now we can deal with angles that are bigger than 90 degrees, but we can also deal with negative angles going the opposite direction. So if you look down here, when it's in standard position, the initial side is always on the positive x-axis. So that's the initial side right there. The vertex is always at 0, 0. And then we have the terminal side. The terminal side is formed by going counterclockwise. So this angle is moving, you can see that angle is moving that direction. So direction does matter when you talk about an angle when it's in standard form. What that means is we can have negative angles now. So if I move clockwise instead of counterclockwise, then we can produce or end up with negative angles. When trig functions are defined using rotations, right, in the coordinate plane, we usually use radians, not degrees. So real quick reminder, we know that it's 360 degrees all the way around the circle. In radians, we say it is 2 pi radians. You see that little r up there? That's just a notation to tell you that it is in radians. So if we set it up that way, what happens is we can form a triangle. So if you look at this angle right here, and we form this triangle, right, even though the angle is, let me do that in a different color. Even though the angle is this angle formed in the red, we can use what's called the reference triangle that's formed. And what I mean by that is if you look over here, take the terminal side and the x-axis, and it forms a right triangle. And we can use that to set up our ratios. So think about it for a second. In this case, if this is the angle we're going to use, the sine would be the opposite, which is y over the radius is r. So you can see that right there, y over r. The cosine is the adjacent, which if this is my angle, it's x over r. And then the tangent is opposite over adjacent, so it'd be y over x. These are the reciprocal figures right here, right? So this is just the reciprocal of the sine. Instead of being y over r, it's r over y. So the secant, instead of being x over r, it's r over x. And cotangent, instead of being y over x, is x over r. If you want to find r is the distance right here. It's always positive, and we can just use Pythagorean theorem, right? These are my two sides. I take x squared plus y squared equals r squared. And then I add those together, take the square root, and we end up with that. X and y can be positive and negative, but r is always positive. So in this figure, right, the x would be negative because I'm going to the left. The y would be positive because I'm going up, and r is always positive. So just think about what the sine and cosine would end up being. If I went to find the sine, in that figure, this y would be positive and the r would be positive, so the sine would be positive. So in that second quadrant, that will always happen. Cosine, the x would be negative, the r would be positive, so it would end up being a negative. Tangent, the y would be positive, the x would be negative, so you'd end up with a negative answer. So you got to make sure when you put it in standard form, you can end up with positive or negative answers for sine, cosine, and tangent. It just depends on the values of x and y. And don't make it complicated. It's just like you learned way back in 6th grade when you did the coordinate plane. If I go to the left, then x has to be positive. So here or here, x is going to be positive. If I go down, then y is going to, I said that wrong, I'm sorry. If I go to the left, the x is negative, right? In this quadrant or this quadrant. If I go down, in either of these two, the y would be negative. So it's just like you learn, x is, if I go to the left, it's negative. Y, if I go down, it's negative going that direction. So here's an example. It wants us to find sine, cosecant, and cotangent if theta is an angle in standard position whose terminal side passes through the point -5, 2. So always draw a picture here. So I know that my angle, the terminal side of my angle, goes through that point right there. So I'm just going to draw that. Right? Let me do that a different color. My initial side's going this way. That's my terminal side. That's the angle. I'm trying to find the sine, cosecant, and cotangent of that angle. What we're going to do is just form a triangle. Now when you form the triangle, you use the reference angle. The reference angle is always between the terminal side and the x-axis that it's closest to. So in this case, that is my reference angle I'm going to use. This is my triangle I'm going to form. And that's a triangle we're going to use to find the sine, cosecant, and cotangent. Okay, so go ahead and start by labeling your sides. We know x is a -5, right? I'm going to the left. It's a -5. The y is a +2 because I'm going up. But I need to know r. I need to know the radius. We'll just use Pythagorean theorem. 2 squared plus -5 squared equals r squared. Or in other words, r is equal to the square root of 2 squared plus -5 squared. So 2 squared is 4, -5 squared is 25. Add those together. R is equal to the square root of 29. We'll put that up there. Okay, now we know sine. Sine is, if this is my angle, sine is the opposite over the hypotenuse. So sine of theta equals 2 over the square root of 29. The cosecant is the reciprocal of the sine. So if I take that one and flip it over, square root of 29 over 2. And the cotangent is the reciprocal of the tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So negative 5 over 2. Though we could find all 6 of them if we wanted to, but those are the 3 they asked us to. Hey, real quick as a side note, some of you may be like remembering that you shouldn't leave it, that sometimes you're asked to not leave the square root on the bottom. In calculus, again, we don't worry about simplifying that unless it's multiple choice and the answers are simplified. But let me just remind you how you would do that. If you have a square root in the bottom of the fraction and you want to what we call rationalize the denominator, we times by whatever the denominator is. So we times by the square root of 29. So that'd be 2 square roots of 29 over 29. And that would be if we rationalized the denominator. I don't necessarily care. You can leave the answer like this. But if you're taking a test, they may write the answer this way by rationalizing the denominator. You just have to recognize that they are the same thing. All right, so it says circular function trigonometry makes us use reference angles and triangles. Okay, and it's not really much different than right triangle trig. Just kind of like we did right there, you draw that triangle. It says think of it as an extension of right triangle trig. The angles we use a lot of are the 30, 60, 90 or 45, 45, 90. So they're really important for us if we want to find those different values on that circular function. So let's draw the 2 special right triangles. So if I have a 30, 60, 90 triangles, I want to not remember you, that was terrible English. I want to remind you of those 2. I'm going to do a different color than that green, that's really bright. If I take a right triangle and say it's a 30, so this is 30, 60, 90. You guys learned these ratios, but it's been a while, so we're going to review it. If the hypotenuse is equal to 2, the short side is always equal to half of that. So this 30-degree side, opposite it, is equal to 1. And then the longer side is always the short side times the square root of 3. So that is your 30, 60, 90 triangle right there. And you just need to have that memorized. The hypotenuse is 2, the short leg is 1, the longer leg opposite the 60-degree angle is the square root of 3. For a 45, 45, 90, so that means that these 2 angles are the same. They're both 45. That actually means those sides are the same too, right? On those, if you say the legs are 1, the 2 legs of the triangle, right? If you use Pythagorean theorem, it'd be 1 squared plus 1 squared equals the circumference squared. So it ends up being circumference squared equals 2. You take the square root. The hypotenuse is equal to the square root of 2. You need to have those 2 triangles memorized. If you have those 2 memorized, this is easier than using the unit circle. When you take the AP test, they do not allow you to use a unit circle. So I know in Math 3 you did that a lot. It was great. And if you have it memorized, you can use that. That's fine. But really, if you can just use these 30, 60, 90 triangles, if you can memorize these 2 triangles, it's easier than using a unit circle anyway. So let me show you how we'd use those. So this one, example 3 says, draw angles in standard position and make reference triangles to find. First time is a cosine of 210 degrees. So what we're going to do is this, figure out where 210 degrees is. So as I go around, that is 180, but we got to keep going, right? Let's see, 210 minus 180 is 30, so I have to go 30 more degrees. So this angle, as I get to there, this angle right here is 30. So I'm going to form this triangle. This is my reference angle. I'll do it in a different color here. This is my reference angle right here. Because it's a 30-degree angle, and this is 90, right? This is a 90-degree angle over here. That means this one is 60. We're going to use that special right triangle up above. So if I have a 30, the side opposite of 30 is 1. The hypotenuse is 2. And the longer leg, right, this is the shorter leg, is 1. The longer leg is 1 times the square root of 3. So now I've got all 3 sides, and now I can find my answer. It was asking me to find, oh, I'm sorry, make sure you're careful with positives and negatives. I'm moving, this point is to the left, so I got to be, x has to be a negative, and it's down, so the y has to be a negative. Okay, we're trying to find the cosine. Cosine is adjacent over hypotenuse. The adjacent is this, negative square root of 3 over the hypotenuse, which is 2. Okay, so there's my answer right there, is negative square root of 3 over 2. So if you know that triangle, every angle you're ever asked to find, unless you're using a calculator, will always involve either a 30-degree angle, a 60-degree angle, so you'd use that triangle we just drew, or a 45-degree angle, so you'd use that second triangle. So B is an example where you're using the 45-degree angle. You got the tangent of 315 degrees. So draw an angle that represents the 315 degrees. So this would be 180. That would be 90 more, so 270. So if I go 315 minus 270, I have to go 45 degrees more. So this angle right here is 45. And that's the angle we use, right? It's always between the terminal side and the closest to the x-axis. We always use that angle right there. So that's going to form my triangle I'm going to use. And again, you just have to have this memorized. If this leg is 1, this leg would be -1 because we're going down, and this one would be the square root of 2. It's asking me to find the tangent. Tangent is opposite over adjacent. So that would just be the opposite of this angle right here would be -1, and the adjacent would be 1. So the tangent of 315 degrees is -1. So again, any angle you ever find other than if it falls on an axis, the x-axis, y-axis, any other angle will always either be a 30, 60, or a 40. You'll be able to draw a 30, 60, or 45-degree reference angle triangle to figure it out and to find that. Okay, so talking about radians, all the way around the unit circle is 3. If you go a full rotation, it's 360 degrees. That means that it is, and that's 2 pi radians. So up here, right, it says 2 pi radians equals 360 degrees. So if I divide both of those by 2, it means 1 radian equals 180 degrees. So if you think about this for a second, I've got, what, pi over 2 down here. So we know that pi equals 180, so half of pi, or pi over 2, would have to be half of 180. So that would be 90. Pi fourths, that's 1/4 pi. Okay, so we know that, let's see, pi equals 180. So if I take 180 and divide it by 4, that would tell me how many degrees that is. So half of 180 is 90, half of 90 is 45. So pi over 4 is the same as a 45-degree angle. Pi thirds, again, pi equals 180. So we're dividing that by 3. So 180 divided by 3 is 60 degrees. Pi sixth, 180 divided by 6 would be 30 degrees. So down below it says convert each from degrees, from degrees, radians to degrees, or degrees to radians. So if I have 5 pi over 4 and I want to convert that to radians, what I can do, let's go back up here. I'll write down a formula. You can figure these out without a, well, actually, let's do it without a formula. If I come up here, 5 pi over 4, the way I'm thinking about it is 5/4 is 1 1/4. So I have to go 1 pi, that's 180 degrees, plus 1/4 more, right? This is 1 1/4 pi. Well, 1/4 of above, we just said, 1/4 of 180 is 90 more. So if I add another 90, or sorry, it's 45 more. 180 divided by 4 is 45. So add another 45. So this would have to be altogether 225 degrees. Hey, 270 degrees, that's like saying 180 degrees plus 90. Well, up above, right, we know 180 is pi. 90 was a half pi, or pi over 2. Well, 1 pi plus a half pi, 1 1/2 pi is 3 pi, 3/2 pi, or 3 pi over 2. Okay, -120. All that means on our unit circle, by the way, -120 just means I'm going backwards. So there's 90, and there's 30 more. So we know that 90 was a half pi, so -1/2 pi. Then I have to go plus, and I have to go, 30 degrees more? Well, we said 30 degrees was 60. I'm sorry, 30 degrees was pi over 6. So really what I'm going to end up doing is, what's a half plus a sixth? So, common denominator, make that 3 over 6. Add those together is 4/6. That's 2/3. So, and it's a negative, right? I'm going a -2 pi over 3. That's a little bit tricky, but if you think of it that way, I think it's a little bit easier. Here's a formula, though, if you like formulas. If I want to go from degrees to radians, you multiply by pi over 180. If you want to go from radians 2 degrees. You multiply by 180 over pi. So if you want to use that formula, if we tried these again, here's using the formula. I have 5 pi over 4. That one's in radians. So I times by 180 over pi to go back to degrees. So the pi's just cancel out. 4 goes in 180 45 times. And then you multiply all those together, you go 5 times 45. Anyway, it ends up being 225 degrees. Get the same answer. 270, that one's in degrees also. So we go 270 times pi over 180. You can cancel out the zeros. I have 27 over 18. Divide both of those by 9, just reduce it. And you end up with 3 pi over 2. Negative 120, that one's also in degrees. So we times it by pi over 180. Again, the zeros cancel out. 12 over 18 divided by 2 comes out to be negative 2/3. So that's using the formula. I don't care which way you do it. You can think of it just where we converted it up above, or you can use that little formula to find it. Here's the opposite. This one's going from, let's see, so since 2 pi equals 360 pi, so this is, if you look at the last examples, right? Actually, these are the last same examples, aren't they? I have 2 pages of it. Sorry about that, guys. So we'll skip past there. Okay, this one says, draw the angle in standard position, make reference triangles, and find the following without using a calculator. We've already done this, but we did it when it was already in degrees. So option number 1, which I think is a poor option, is you can switch it to degrees. We really ought to just get used to doing it in radians. So 5 pi over 6, here's the way I think about it. I know that all the way to there is 1 pi. Well, 5/6 is almost all the way there. So what I'm going to do is go like this. I'm going to go all the way to right there, draw my triangle. What I'm really worried about is this triangle right here, so I need to figure out this reference angle right there. Well, if I go 5/6 of the way to pi, that means this one is 1/6 pi, or pi over 6. Now, pi over 6, this is where, if you know pi over 6, pi over 4, and pi over 3, that can make your job real easy. Pi over 6 is 30 degrees. Oops, sorry about that. So this would be 30 in here. So go ahead and draw your triangle. The side opposite the 30 was R1, the hypotenuse was 2, and the longer leg was square root of 3. It wants me to find the, oh, and make sure we're careful with signs. The 1's positive, but the square root of 3 is negative because I'm going to the left. The tangent is opposite over adjacent. So the opposite is 1. The adjacent is a negative square root of 3. And you can leave the answer like that. Now, you may just know, if you're on a multiple choice question, they may rationalize the denominator. If they did, you would times by the square root of 3 on the top and the bottom. So you'd end up with a negative square root of 3 over 3. Okay, so that would come out to be. Look at 7. Cosine of negative 3 pi over 4. Hey, the negative means I'm moving backwards, and I'm going at 3/4 of the way, right? Pi is all the way to here. That's pi. We're going 3/4 of the way, though. So there's a half of the way to pi and 3/4 more. This is going to be my reference triangle right there. Figure out what this angle would have to be. Well, if I go 3/4, this would be 1/4. Well, 1/4 pi, that's really 1/4 of 180. 180 divided by 4, it's 45 degrees. So this is really a 45-degree angle right there. So set it up. We know the hypotenuse is, if the legs are 1, the hypotenuse is square root of 2. And we're trying to find, and make sure you label signs. I'm going to the left, so negative 1. This point down here, right? I'm going down, so negative 1. Cosine is adjacent over hypotenuse. That's the adjacent, that's the hypotenuse. So it'd be negative 1 over the square root of 2. Which again, if you rationalize the denominator times by the square root of 2, you'd end up with negative square root of 2 over 2. Either one of those answers is fine. Cosecant of 5 pi over 3. Sometimes we see the cosecant, we have like panic. Don't panic. Just figure out draw the triangle again, and then we'll figure out what the angle is. We'll label our sides, find the right triangle that fits it, and the very last thing we'll do is worry about the cosecant. So 5/3 pi. 5/3 is 1 2/3. So I have to go 1 pi. This would be a half. 2/3 would be somewhere over here. So it looks something like that. Well, if I went 2/3 of the way around here, that means 1/3 left over here. So that's pi over 3. Hey, pi over 3 is 1/3 of 180. It's 180 divided by 3. That means it's 60 degrees. This is a 60-degree triangle. Okay, that's my right angle. It's a 60-degree triangle. We're using the same triangles you did in number 6. This time, though, if this is 60, the opposite side is the longer leg, so it's the square root of 3. This is a shorter leg. It's 1. And then the hypotenuse is 2. Now label, make sure positive or negative. The 1 is positive because it's going to the right. The square root of 3 is negative because it's going down. The hypotenuse is always positive. Okay, cosecant. Make sure you figure out which one it goes with. Cosecant goes with sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over the opposite. So the side opposite angle would be this one. So again, that'd be -2 over the square root of 3. Or if you rationalize the denominator, you times by the square root of 3 on the top and the bottom, you would end up with a negative, 2 square root of 3 over 3. Okay, if you rationalize the denominator. All right, so unit circle, used this a lot last year. We're mainly going to use the unit circle to find a 90-degree angle, a 90, 180, 270, 360. Anytime you land on the axis, I can't draw a triangle anymore. This is where the unit circle comes in handy. What happens to the unit circle is you make the radius equal to 1. Well, if the radius is equal to 1, then the sine would be opposite over hypotenuse would be y over 1, which just makes it y. The cosine would be adjacent over hypotenuse would be x over 1, which would just make it x. So if you're using unit circle, you don't have to go y over r. The sine is just y. The cosine is just x, and the tangent is just y over x. Well, the reason why we're going to use unit circle is at pi over 2, that point is easy to find, right? That point is 0, 1. At pi, that point is at 1, 0. And we don't need to memorize these because you can just think about you can just look at the graph and figure out what these are. This would be 0, -1. I did that wrong. That should be -1, 0, right? 0, -1. Let me rewrite that. So 0, -1, and this one would be 1, 0. Okay, so what that means, if I find, let's do this. If I do let's skip A, the sine of pi over 6. Let's do the sine of 0. Well, 0 degrees is right here. My terminal side and my initial side are right there together. This is the point that goes with it. The sine is just the y coordinate, so it's just equal to 0. The cosine of 0, same point, same location, but now it's the x coordinate. That would just be equal to 1. The sine of pi over 2, that's right up here. Sine is the y coordinate, so it equals 1. The cosine of pi over 2 is the same point. It's equal to the x coordinate. The sine of pi, so we're right here, sine is the y, so it's just equal to 0. The tangent of pi, so same point. Tangent is y over x, so that'd be 0 over -1, which is just 0. Sine of 3 pi over 2, that's down here. Sine is your y coordinate, it would just be -1. Cosine of 3 pi over 2 is the x coordinate, that would just be 0. A cosine of -pi, doesn't matter what direction you go, it's where you end up. So if I go this way, I still end up at this point. So it's this coordinate right here that we're using. Cosine's your x coordinate, it would just be -1. Tangent of -pi over 2, that again, going backwards to right there, that's a half pi. It'd be this point right down here. Tangent is y over x. That would be -1 over 0, which is undefined. So if you get an angle that's on the x or y axis, then I would just think of the unit circle. Draw a quick little grid there, put your points on there, figure out where it's at. And remember, sine is your y, cosine is your x, and the hypotenuse is always 1, or tangent is y over, so that makes tangent y over x when you go through and find that. And by the way, the sine of pi over 6, unless you're going to memorize unit circle and figure out what all these points are, I would suggest not to. But if you were going to, you could just look at that point and use the y coordinate. But I wouldn't do that. Instead, I would do just what we talked, the way we've already done it. Pi over 6, whoops, sorry about that. I'm just going to draw it like this. Pi over 6 is, right, pi is 180, so pi over 6 would be 180 divided by 6. That's 30. So that angle is right here, that angle. Draw your right triangle. This is a 30-degree angle then. That means this side is 1, the hypotenuse is 2, and this is the square root of 3. And we want to find the sine of pi over 6. That would just be the opposite 1 over the hypotenuse 2. So I wouldn't use a unit circle to find any other angles unless they're 0, 90, 180, 270, or 360. Unless it falls on the x or y axis, that's the only time I would use a unit circle. And I know that's a little different from the way you learned it last year, but it requires less memorization. So, right, it says, as you see from example 9, the unit circle is particularly useful in finding trig ratios for the quadrant separators. In other words, on the x or the y axis where you can't make triangles. Sine and cosine are the two most important trig functions. We're going to use those over and over again. Those are the two most common ones you'll see in calculus. But we can use, the other trig ratios can be built using sine and cosine. So tangent is really just the sine over the cosine. The cotangent is the reciprocal, so if you flip that over, it's the cosine over the sine. The cosecant, we already talked about this, but it's the reciprocal of the sine. The secant is the reciprocal of the cosine. Example 10 says, if sine equals 3/5, find the possible values for. So this is a little bit tricky, but what we're going to do, again, is draw a picture here. If the sine is 3/5, remember sine is equal to the opposite over the hypotenuse. But as a quick thought about this, remember you can get positive and negative values here. If the hypotenuse is always positive though, so if the sine comes out to be a positive, that means that 3 has to be positive also. So if I draw my triangle, the y, or the opposite side, has to be 3, the hypotenuse has to be 5. We can figure out that side using Pythagorean theorem. So let's use Pythagorean theorem to find it. So it would be 5 squared equals 3 squared plus, let's just call that x squared. That's 9, that's 25, so you subtract it over. 16 equals x squared. Take the square root, right, plus or minus 4. So that could equal 4 right there. I want to point out that if I come up over here to this side, that hypotenuse is also 5. That y is also 3. That would also give us a positive 3/5. So I think there's actually two possible things that could happen. It could be in the first quadrant, or it could be in the second quadrant. Okay, to find the cosecant, that one's easy because if the sine's 3/5, the cosecant's the reciprocal. It has to be 5/3. Find the cosine. Well, we got those values there. It says the cosine is the adjacent, which is 4, over the hypotenuse, which is 5. So it could be 4/5, or if it ended up being this triangle, it could be a negative 4/5. So let's just we could put a plus and minus in front of that, but it's either a 4/5 or a negative 4/5. Hey, tangent is opposite over adjacent. So if I come to this first one, this is opposite over adjacent. That's 3/4. Opposite over adjacent, that'd be 3 over negative 4, so it could be a negative 3/4. So if you can draw those triangles to solve that, but make sure you take into account that a lot of times, just because the sine is 3/5, it doesn't tell us what quadrant it's in, because I could get the sine being 3/5 there, right? Positive 3 over positive 5. Or we could get it right here, right? Positive 3 over positive 5. Like, they both work fine. So it says solving a trigonometric equation requires you to work backwards. In other words, in this case, you know what the answer is, and you have to work backwards to figure out what your angle is. So example 11 says, solve the following trig equations without using a calculator. Find all the solutions between 0 and 2 pi. We'll talk about why that's important, because it is important. Okay, so the cosecant is negative 2 over square root of 3. To solve these, I'd always start out by saying, let's figure out what the opposite, adjacent, and hypotenuse is. So cosecant's the reciprocal of the sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. So let's label that hypotenuse over opposite. Okay, then let's draw a picture. Hey, which, by the way, the hypotenuse can't be negative. That's the same thing, right? I can think of the hypotenuse as being a positive 2 and the opposite being a negative square root of 3. That works. And then let's draw a picture here. So let's see, I want the hypotenuse to be 2. I want the opposite to be, so opposite means down. That's the y. So that means my point's going to be here or here. right? That's a negative square root of 3. That's a negative square root of 3. That would be 2. Hypotenuse is 2. Either one of those would give me a cosecant of a negative 2 over the square root of 3. Okay, let's figure out what the adjacent side would be. So you can use Pythagorean theorem. If I take 2 squared equals square root of 3 squared, you can put a negative in there, but it's going to be positive, plus x squared. You'll see that's 4 equals 3 plus x squared. You minus the 3 over, you get 1. Take the square root, you get plus or minus 1. So it could be 1 or negative 1. Okay, now let's figure out what triangle that goes with. That's one of our special triangles, right? 1, square root of 3, and 2. That one goes with our 30, 60, 90. Remember that square root of 3 is opposite the longer side, so this has to be the 60. The 30 is down there, so it's a 60-degree angle there. Okay, now we got to figure out what that is, and we're going to do it in radians. So if I go around, this is pi, then I have to go 60 more. 60 more is a third of pi. So that would be pi over 3. So pi plus pi over 3, that's 1 1/3. That makes it 4/3. So one answer would be 4/3 pi. I'm going to put it down here. 4 pi over 3. The other one is going all the way around to here. So this would be 270, and that's 30 more. That's 300 degrees. So you got to figure out what 300 degrees is in radians. Well, that is, let's see, 1 pi plus 2/3 more. Okay, going that way. So that'd be 1 2/3, which actually ends up being 5 pi over 3. That's a little bit tricky. It takes some getting used to. You guys will get it. I believe in you. Hey, cotangent square root of 3. Make that into a fraction, square root of 3 over 1. So we know that the tangent is opposite over adjacent. So the cotangent is adjacent over opposite. Okay, so we got to draw our triangle. So we know the adjacent is, and one thing to keep in mind, to get a positive, it could either be a positive and a positive, or if they were both negatives, it would also come out to be a positive. So if I have a positive and a positive, it would be up over here. And we're going to go, the adjacent, which is the x, is square root of 3. And the opposite, which is that, is 1. By the way, if you recognize that, this side has to be 2, right? That is a 30, 60, 90 triangle. So they could both be positive. They could also both be negative. So I could go to the left, square root of 3, and down a negative 1. That would also give me a positive. Okay, so make sure you identify, this is the 30, 60, 90. Decide if this is 30 or 60. This is the short leg, so it's 30. Well, 30 is pi over 6. This one you have to go 180 plus 30 more. So that's pi plus pi over 6. So 1 1/6, which is 7/6 pi. Oops, sorry, 7 pi over 6. The reason why we have to limit it between 0 and 2 pi is, right, I've got that, I've got 30 degrees, I've got, what do we say that was? That one is what, 210 degrees? If you kept going around, we'd hit that point again, and you'd hit that point again, and you'd hit that point again. So there's actually, if I take off that part, there's actually an infinite amount of answers. So what we're always going to do is just limit it to one time around the circle, right? 2 pi is 0 to 2 pi is just one time around the circle. You're only looking for the answers in there. Okay, our last problem here. I know this has been a lot. Like, there's a ton covered in this chapter. We're covering basically a week's worth of trig or more in one day, but it is what it is. Okay, we want to solve for the cosine squared. So I'm going to add the 1 over. 2 cosine squared of theta equals 1. Cosine squared of theta divided by 2 would be 1/2. It makes a note up here. Hopefully you remember this from last year. Cosine squared of theta means this. So this really means cosine of theta squared equals 1/2. So I've got to take the square root of both sides. So the cosine of theta equals square root of 1 over the square root of 2. So that would end up being cosine of theta I should put plus or minus out in front of there, right? Plus or minus 1 over the square root of 2, right? If I take the square root of both sides, you have to put a plus or a minus. Okay, we're going to come down here then and figure out when I get those. So I've got 1 in the square root of 2. It could be a positive or a negative. So right up here, you could form a triangle. That would be 1, 1, square root of 2. That would be a positive 1, right? The cosine is adjacent over hypotenuse would be 1 over the square root of 2. You have another one over here where the adjacent would be 1 and it'd be square root. This would be a negative 1. That'd give me a negative 1 over square root of 2, which is okay. I have plus or minus. We could also come down here and have another one. This would be negative 1 over the square root of 2. And we have another one over here where that would be a positive 1 over the square root of 2. So you actually end up with 4 different points where the cosine would either equal 1 over the square root of 2 or a negative 1 over the square root of 2. Find those angles. Well, this is our 45 degree angles. This is 45 degrees. 45 is 1/4 of 180. So it's 1/4 of pi. So one of my answers is going to be this one right here. That's a pi over 4, or 1/4 pi. This would be a half plus a fourth. That's 3/4. This would be 1 plus a fourth. That's 1 and 1/4, which is 5/4. And then if I go all the way around here, that's 1 1/2 plus another 4. So it's 1 3/4. So that would be 7/4. If you remember how to convert from a mixed number to an improper fraction, that will be helpful for you here. Again, this is a lot. There's a lot of stuff here. This is basically everything you covered in Math 2 with Trig, along with about half of what you covered in Math 3. And we're all throwing it into one unit to kind of remind us here. Do the best you can. Like, it just takes practice. It really does. So it's going to feel overwhelming and confusing. Use your notes, look through it, do the best you can, ask lots of questions. Oh, I forgot the clever thing at the end, right? For these problems, you must be careful with your signs. Ha ha ha. Very clever. All right, thanks guys. Have a good one.